Hello world, welcome to another live. I hope you peoples are doing good and fine. We are going to see some interesting automation in today's live. Some new technology related videos we will talk about in later of this live. As per the title itself, you peoples will understand what we are going to do, what we are going to see. But however, I will walk you peoples what we are going to see in today's video and how it going to help you, and you will get some knowledge in this life. I hope so. Let me set up my other things so that you can easily recognize what I am going to share. So I'm going to share my screen, my entire screen. Okay, good. Okay, so my screen is visible, I thought. Okay. In today's video, we are going to see one of the interesting thing that happens in mobile application automation. Even if you are a web developer, you will know a little bit about the automation, whether you are going to push your latest code to the live so that people can use your latest updates. This happens same via in the mobile applications too. So we can say it as a app distribution system. So in instance, there are a lot of other tools that provides app distribution. One of a famous thing we can say like Firebase, which produces app distribution system where you can deliver your application to the testers or the live application to the stores, but mainly it is for the app distribution system for the application delivering the release or else the test release to the testers and other developers, where they can test the application how it works. So I will show you the instance of what is the Firebase app distribution system is. So this is what happens. So it is automating the app releases to the testers. So we are going to replicate this thing, not exactly as same as like, but how a system of app distribution by our own custom server and GitHub Actions. This is all about today's video. So for this, let us say what are the things you need to get started with. So I'm going to note down here in the notepad so that you can easily understand what are the things you need to get started with. Okay, so the first thing, you need a client side. For my client side, I choose the Flutter, which where we are going to develop or else there we are going to build the application, mobile application, and we are going to deliver it to the testers. Whether you are a React Native person, you can also stick with this video, but somehow you can swap the ideology or the architecture of the Flutter instead with your React Native codes or React Native build commands or React Native build release commands, whatever maybe you call. But here I take it as a client side as a Flutter because of I'm going to develop, or else I need to produce the build for the cross-platform applications like Android as well as the Windows. This is my target. This is my target builds. That's why I will go with the Flutter. And also I'm mainly developing a Flutter application. I'm going to deliver that application builds to my testers or else to the users as an insider preview. So that's why I stick with my Flutter project itself as a client. This where we will develop, or else where we will provide the release. And second thing, what you need to do is that you have to upload your client code to the, obviously, the GitHub. You have to upload your client code to the GitHub, where we will access the GitHub Actions. So what is the purpose of this GitHub Actions here is that we are going to automate the build of this client-side application by using these GitHub Actions. So simply we can provide the build with whether it is a release or it's a profile version. That can be done from our local machine. We can produce the builds to the testers or else to the client for the democratic test or whatever may be. So, but here, instead of building that app or in the release or profile, what are the versions in our local machine, we are going with the GitHub Actions, which will automate our build and it will distribute to the third point, which is our custom server. So this custom server is nothing but will take this GitHub Actions provided build and it will pass over to the front end where the testers or else the users will get, or else whether they can access that build release. So this custom server will handle the builds from the GitHub Actions to the front end showcase where the users can access or the testers can access that build. In my condition, what I have done is that instead of making a different front end to showcase the builds, I have made a front end inside my own distribution server itself. So here this custom server will act as a distributor as well as the showcasing, or else it will show, or else it will paint the UI. So it will make the two things in one hand. So it will access this GitHub Actions release builds and it will show it on the front end. These two things happen in one custom server itself. Here I have taken the Node.js and Express.js as my backend. So these are the three things you need to achieve the replicate of Firebase app distribution systems. Or else if you can also add some cloud things here. Like for example, here what I have done is that my build can be processed to the custom server. It is not the cloud instance where I cannot permanently store my release builds and I cannot provide the history of applications builds. Instead, I can only show the build for several minutes or several amount of time. So after that time, automatically that build will get erased inside the custom server storage. So if I want to, once again, I want to produce that build, what I need to do, I need to restart the actions or else the workflow again to produce a new build. So if you want to connect or else if you want to produce the previous history of application builds, what you can do, simply you can connect a cloud service where you can deliver that builds to the cloud and you can get that access of the builds from the cloud and you can show it on the front. So these both achieves the same thing, but instead of accessing the cloud and making it as a so much difficult one, I made it simple and efficiently working one. So this is a simple replication of Firebase app distribution system. So let us get inside this architecture a deep one. So first let us move to the Flutter client side. So first one what we need to do is that here I have my project inside my GitHub. So imagine this is my client side here. This is my client side code. So inside my client side code, whether it can be your root, sorry, it needs to be your root directory. For example, air underscore bridge is my root directory. Inside my root directory, what I have done is that I have created another directory called .github slash workflows. .github is a directory, and inside the directory, I have another workflows directory, which is going to handle all the automation workflows for this project inside the GitHub Actions. Simply with the GitHub Actions, you can automate whatever the things you want. So, but here, what we are going to do, we are going to automate our client-side application build with this GitHub Actions inside this workflows directory. As you can see, I have three YAML files. Three of the YAML files are different. One of the YAML file you can see measure app size. This is another workflow. I have recently made a video on this, how to calculate your application size. If you want to know about this, check out the card I will place out, or else you can check out the description to learn more about how you can make your own app size automation checker via these GitHub Actions. But right now I need to go inside the CICD YAML file, which is going to handle our CICD build pipeline. Simply, you can also call it as a pipeline. It is not the exact DevOps workflow, but somehow it mimics the Git DevOps pipeline for the build and distribution system. So here, this is my YAML file content. Simply inside the workflows directory, you need to create a YAML file. It can be whatever the name you can provide, but simply I have provided CACD YAML file. Okay. So inside this YAML file, first what I need to do is that I am going to name the YAML workflow. The GitHub Actions workflow name. Simply CICD build and distribute. So on push, I have mentioned is a manual workflow, which it should not trigger automatically when I push the code, because of this build and distributing the build applications is a major expensive task. So I don't want to trigger each and every time when I push the code. So here I then make it as a manual workflow, which means once I done working with the code and I will push the code, this repository of my GitHub will have the latest code. So what I will do, I will go to the GitHub Actions. Over there, I will trigger this CICD build and distribute. This comes because of the YAML file. Once you have created your YAML file, automatically inside these actions, you can see this YAML name, where I have already shown you this thing in the YAML file as the name. You can see name CICD build and distribute. This is the name will be provided here in the GitHub Actions in the workflow name. So this is a manual thing. So I need to manually run this process. I think it is a healthier one instead of running it in a most automatic way, which is once you push the code to the repository, automatically it will start the build. This can be also done, but if you do like this, each and every time you push your code, automatically it will trigger a build one by one, one by one, one by one. This will be an expensive task when you are going to build the application for the cross-platform devices like Android, Windows, and furthermore. So if you're working with only the Android, I think you can go with the automated one. But if you're going to provide the build with the different platforms, I think automating this entirely will cost you an expensive task. That's why I made it as a manual one. So in see this once again, we will go to the YAML file itself. Okay. So inside this YAML file, show on push, I have mentioned the tags and workflow dispatch. So what is this env? What is the purpose of this environmental line? This environmental variable is provide it will provide the access to my server, and also which will eventually connect with the token, which will make this build and produce to the server and secure one, because you don't want the others or else anybody to access this server build easily. That's why we have secured it, and also we have provided the server url in the environmental variable, so that none of the people will easily access this workflow, and you cannot and they cannot misuse this. So if you want to do this, what you need to do, just mention the secret distribution server url and token key inside your settings and secret variables. Set it on. That's all. You're done with the environmental variables. Here in this distribution server URL, you need to provide your endpoint. I will say what is the purpose of this server URL endpoint in the later in this video. But right now, just simply imagine this is just a distribution server endpoint where we are going to push the builds to this endpoint as a post request. Second, I need to mention the jobs. Here we can mention the multiples of jobs what where the GitHub Actions needs to done. So I have two jobs here. One is to build for the Android. Another one it needs to build for the iOS. So which means I have two different workflows of task in this GitHub Actions. So let us explore how I am going to build this, or how I am going to produce this for the Android one. So first, this GitHub Actions is nothing but simply you need to make a virtual machine like your exact local machine inside the GitHub Actions or else GitHub Cloud. So first of all, what I have made a operating system to work with this inside the virtual machine, which is an Ubuntu latest, mentioned as a runs on, and the timeout minutes I have set to the 30 minutes, which is nothing but the maximum amount of time this workflow will run. If it reaches this limit or else it exceeds the limit, automatically the workflow will be terminated. This is essential to control your workflow inside this virtual machine. Sometimes GitHub will also make some cost while you are working with these workflows, automation related things. That's why I have mentioned the timeouts, meaning up to 30 minutes, but it can be looks like it is a higher amount of time. Why I'm mentioning 30 minutes? I think if you're working with Android or else any particular single platform, a maximum amount of 20 or else 15 minutes is enough. But you're working with the multiples of platform, you need to maximize this timeout minutes. I don't know why it takes to build a Android version of my release, because it takes a lot of amount of time. Eventually it crosses the 20 minutes in some cases, but in some cases it consumes less than a 15 minutes, but somehow I maximize to the 30 minutes. Next, I need to mention the each and every step that needs to make the build of our client side. So first thing, I need to make sure the virtual machine is ready. So I have mentioned the checkout code action checkout at b4 fetched up 0. Next, I need to set up Java to make an Android build, which is super necessary here. So what I need to do is that I need to mention actions setup Java at b4. Distribution Java 0 and Java version is 17. Make sure you're changing this Java version, because of according to your project it may vary to your projects. So make sure you are providing your correct Java version here. For my project is the Java version is 17, and the distribution Java is I'm going to select with the Zulu. Whatever maybe it's up to you, and it's up to your project. And the next thing, once I have set up with the Flutter Java, next I need to go to the Flutter. Obviously, we need to install the Flutter inside our virtual machine. So what I have done, I have provided a name setup Flutter and sudo Flutter actions at v2. Here I have mentioned a particular Flutter version. This is a 3.29.0. if you are working with some other versions or some other flavors of Flutter, be sure to mention here, because of right now for my this or else this repository project access or else works with the Flutter version 3.29.0 particularly. That's why I have mentioned here. And the channel is stable, cache true. If you are going to provide this cache to true, which will eventually fasten your build process after the completion of first build release. For example, let me say you have completed one single build release with this GitHub Actions, and you are going to make the another release after the 5 minutes or else after the 20 minutes of build time. So which will eventually boost up the build process on the second instance if you have cached the Flutter setup here. That's why I have mentioned cache to true. Next, this is an optional one, because if you are working with some specific NDK versions, Android NDK versions, you need to mention here. Since I am working with specific versions in each and everything, I need to mention it each and every Android versions, Flutter versions, and Java versions too. So here I am working with this particular NDK version. That's why I mentioned and also installed this particular NDK, Android NDK. So I have named it as install Android NDK. Next, so I have printed installing Android NDK. So once this Android NDK installation is completed for this particular version, we can move to the next step. So here I have fixed one thing. Previously, what I have done here is that I have made a build for the debug version just to test with the debug release signing keys. But after some analysis, I have changed this to the release signing key with some technical depths of architecture. Because even though this entire thing looks like some little bit of confusing one, since we are replicating an entire new ecosystem which was developed by an MNC company, it is not an exact easy way to or else easy door to open and get into something. It will be a little bit difficult to do. So one of the difficult thing I have managed to and I have solved it is that using the release key. As we all know, if you are a mobile app developer, absolutely, if you want to provide a release version to into the stores like Play Store, obviously you need to first sign in the application. So here, what I have previously done, I have mentioned the debug signing key, but after some research, I have turned into the release key. Here I have done is that you need to provide upload key store signing key before you are going to make a release for the Google Play Store for the first time. So these kinds of key store sign-in file cannot be directly uploaded into the GitHub, and it cannot be accessed by these GitHub Actions. So what I have done here is that first, for the higher level security of this key store signing, I have converted this Android key store signing JKS file into a base 64 file, which will eventually looks like some kind of like SH256 characters of code. That base 64 can be easily decoded and analysis and can be converted into JKS file while on time on the GitHub Actions workflow. So here first, but that conversion of JKS to base 64 needs to be done on your local machine, and that particular base 64 file needs to be uploaded into the GitHub repository. Like you can see, my key store signing file, one of the copy of the original one is present on my local machine. What I have done, I have completed, I have converted that JKS file to the base 64 text file. I cannot show it right now for the security purposes, but simply you can do this by following these steps. I will mention those command to convert this JKS file to the base 64 txt file in the description. Don't forget to get that one. So once I converted this base 64 txt file, I need to decode and access those Android key store password, key alias, and key password inside my secret variables. Because as you know, if you are making the sign in keystore jks file inside local machine, you will know that store password, key alias, and key password. What is the main purpose of mentioning these store password, key alias, and password is nothing but this is a base64 file. Once we convert this base64 file into a JKS on time on this GitHub Actions, you need some permissions to access this, which will eventually ask you for the store password, key alias, and key password. That's why don't forget this store password, key alias, and key password while you are creating on the local machine. Save those and provide it in a secret variable so that while converting from the base 64 to the JKS on time, this will be helpful for you to access that JKS file. So this is the decoding release keystore one. Just some bunch of codes to convert that base 64 into a release.keystore file. After that keystore file is converted, I am going to apply those password. I am going to access this and I am going to mention the release sign-in key. Second step, this is the optional one to boost your Gradle performance. So if you want to make your entire build optimum and in the performant way, you can code this up. Or else if you don't want and it is a small project and don't want to make this performant way, this is the smallest project which will eventually complete in less amount of time, you can neglect this entire setup Gradle performance. And the third and the last is a builds one. Build Android APK file. This is an APK file, but if you are willing to provide that .abb file, you can do that too by simply changing this command to the ABB release command. But right now, this why I'm doing the APK file release to the distribution is that I can make this access to the testers easily for their devices. And second thing, one of the most thing, I can provide this APK release as an insider preview to my real users too, whether they want to whether they want the access to the early versions of our application or the future. So here I have what I have mentioned. I have mentioned the command flutter build apk hyphen release hyphen split hyphen bear hyphen ab. Target platform is obviously ARM64 version. If you want specific one, you can also mention here. So one thing, if you are a React Native person, just simply tweak two things here. I hope so, but I don't know whether it is right thing. But you can easily analyze this thing. I think we have we have several things in common, which is set up the Java, whether it is also an NDK setup and keystore setup. These are all common things for us, whether you are working with a Flutter and React Native. But what are the things here will change is nothing but accessing your React Native repository for the or whether you are working with the Expo one, you need to change this here according to your Expo or a native React Native. And then here will also change the build command. Here I have provided the Flutter build APK, but if you are working with the React Native, you can change this to some other command according to a React Native build release. So once the build is done, we need to push that build from the GitHub Actions to our custom server. So here, what I have done, as I have said earlier, I have an endpoint to get this APK file. Now I will show that endpoint to get that file. This is also inside my repository. You cannot access my repository since it is a private repository. But just for the educational purposes, I'm showing this project. I'm showing this private repository. So inside my backend code, I have a particular route to get that build. As you can see, I have built pipeline inside my Node.js server. First, I have created a temporary disk to store those builds. This is the code to make that temporary disk. But before that, let's explore that build artifact. So this is the endpoint which is going to get that APK file, and which eventually will show the build releases in the front end. So it will accept as a single artifact file. Next, it gets some 5 kinds of data from that APK file, or else whatever the file you are going to deploy, or else you are going to upload: version, platform, commit hash, branch, and build type. So make sure our GitHub Actions provide an exact file to the server before we are going to show in the front end. Once this requested fields has gotten, we will upload this entire APK file into our local disk. Let me explain one by one here. So once we get the version, platform, commit hash, branch, and build type, we'll check for whether the file is really present inside that request body. If not, we will going to show there is no file inside that endpoint to our GitHub Actions. Next, if the missing fields can be filled with these dummy versions like version, platform, commit hash, and branch. Once this is like, for example, if any one of the thing is missing, or else like any kind of how can I say, like if the branch is missing, the commit hash is missing, this can be complemented and can be provided as a default as commit hash, branch, platform, and version. But apart from that, you cannot neglect the entire artifact file inside this endpoint. Next, I'm going to provide the file name for this storage, or else the stored file inside our, or else which we are going to eventually showcase in the front end with this correct file name. Platform, version. Like for example, if I'm going to build for the Android, it will show here Android. If I'm going to build for the Windows, here it will show the Windows. And version, this version eventually increases. Not sorry, I have said the wrong one. It will not increase, but it will provide a random version here of that file if we have provided the file version inside your project. And it's going to take the date of current, or else uploading date and time. Next is going to make the path extension name and the file original name. Next, it will be stored inside the /build/platform correct file name. For example, here you can see once you test this endpoint, automatically it will create a folder inside your server. This is a temporary folder which is going to store your Android and whatever the platform builds. Here we have Android latest builds currently present, but this is a dummy version. I need to delete this one. In future, I will do it right now. But once the automation completes, automatically that Android build or else the Windows build, whatever the build, can be stored inside in a separate folder like /build/platform name. If it is Android, it will store as Android. If it is Windows, it will create a Windows directory and it will store that Windows build inside the Windows directory. So this is to ensure that whether the build directory is present. If it doesn't, it will create a directory over there. So remember this is a recursive one which will eventually override the previous builds too. Now we are going to provide the build info, ID, file name, original file name, version, platform. This is some kind of a build info. This is not much necessary for you. But if you want to store those inside a custom JSON file, where you can access it, or else where you can get the latest releases of application, or to want to know the application size and other things, you can store it on the different JSON file by mentioning this build info, which will eventually get the ID of that build and file name, original file name, version, and what kind of platform you are going to build, commit hash, branch, and whether it is a build type, it is a profile build or debug build or as a release build, timestamps, size of that file, and this download URL to be mentioned inside the front end. That's why we are mentioning this download URL. Next, MIME type, what is the file type. In some cases for the Android, it will be .apk file, but for the Windows, it can be .exe or .zip file. So we are going to get that MIME type obviously here. Those build info can be stored in the build.json file. Next, we are going to push this entire into the directory, and we are going to access from this, and we are going to push this to. This is the directory go to get that file and to show it on the front end. You can see /builds/builds.json. We are going to access this JSON file, and we are going to show. Inside the JSON file, as you can see in the previous step itself, we have storing that we are mentioning the download URL, which is also a directory inside of a server to access those files. And there is also another endpoint to download those files, where user can download those files from this. I will provide this code inside my description, or else as a separate file, and I will mention inside the drive, and I will share it and I will also mention in the drive or in the description, or else in the comment. So this is how you can make your own custom app distribution system. So I will demonstrate how I have done. Let me get to my client side of the Flutter application. You can see this is my inside the GitHub Actions. I can trigger a workflow here. CICD pipeline. If I press this run workflow, automatically it will run the YAML file, and it will distribute the build to my front end, which is nothing but this is my front end, which is hosted on free render service. That's why it takes a lot amount of time to load. So don't mind that. In the meanwhile, I will draw my structure and other stuffs in the Paint software. How this is done. Okay. So imagine this is your repository. Repository for client code. So this is the repository of a client code. Here the code runs by the virtual private machine. Or it's virtual private network inside the GitHub Actions. Inside the GitHub. Once the build is done inside this repository, it will pass that build to the server endpoint. This is a server with local storage. What the server will do? This server will get that build file. Build file. It can be like, for example, we can say .apk file, .exe file, or some kind of zip file for the Windows Store. It will eventually get those files via some kind of endpoint, and it will store these apk or exe.zip file inside the temporary storage of the server itself. Once it's done, next what it will do? It will throw the build to a front end. in our case, this front end is also hosted on this server. So this was pushed by the server itself. In the front end. So this is the simple architecture of creating your own custom app distribution system by simply doing these three things: create your own client side, upload the code to the repository, make a build pipeline, bypass the build to your own custom server. So my front end website is ready. This same thing is also shown by the server. The down thing you can see developer builds. This is a test one. Inside this developer build, once a CDC pipeline completed the build, it will build and push the apk.exe file to a front end. To a front end means nothing but inside this front end website. Here you can see, here you can get that Android, Windows, whatever the build. And we also implemented some custom filters here to get their exact platform. But right now there is no build, since this entire thing is built on top of our own custom server itself, which uses temporary storage. The apk or exe or whatever the file will only stand inside the server for several amount of time. Once the time is reached, automatically that file will be erased. But if you want to show all those builds permanently here, like you can show the previous builds and you can show some previous versions for your users to make them ease for the older devices, or if you want to make comparison between the previous version and the current version with your testers, simply you can swap this test with the custom server. Like for example, what you can do, you can flip this apk, or else you can flow this apk file to some sort of cloud services, like for example GCP, AWS, or Azure. So you can store these apk, exe, and zip files inside these cloud services. And what you can do, simply you can fetch those files from the cloud service via this server and you can show it on the front end. You can do like this if you want to provide the previous versions to the testers or else to the users. But for me, this is an expensive task because I need to push this entire apk, exe, and zip file to the cloud. For the one solo developer, this is an overkilling architecture. That's why what I have done, I have removed this cloud process and simply I have stored inside my own custom server storage and pushed pushed it to the front end and show it over here. So once my latest release is pushed from the GitHub, it can be shown inside this build and you can download these release versions. But for it happens in a certain amount of time. So this is the entire video about making your own custom app distribution system. I hope you people understand the architecture and how it works. And I will catch up in the next video and next live. Thanks for watching. Bye bye. See you.